The ocean does not hurry. Waves cross entire basins without concern for deadlines. Currents take decades to complete their slow, circular journeys around the planet. The deepest waters of the sea were last touched by sunlight centuries ago, and yet life persists there, carefully adapted, quietly enduring. For most of human history, the ocean was seen as chaos, an unpredictable force that destroyed ships, erased coastlines, and reminded people of how small they were. But as science learned to listen more closely, a different picture emerged. Beneath the surface, turbulence lies a system defined not by speed, but by patience. This matters because modern life is built on urgency. We measure success in quarters, not decades. We reward reaction, not endurance. We expect clarity quickly and results immediately. The ocean operates under different rules. It shows us a world where survival depends on restraint, timing, and an understanding that progress often happens too slowly to notice. The ocean is Earth's largest living archive. It stores heat, regulates climate, and carries the memory of past worlds in its chemistry and sediments. More importantly, it reveals a lesson that science took centuries to understand. That survival is rarely about dominance or speed. It is about alignment with long-term forces that cannot be controlled, only respected. When we look closely at the ocean, we are not just studying water and life. We are studying time itself. And in doing so, we may learn something essential about how to live with uncertainty, pressure, and change. For thousands of years, humans could only observe the ocean from its surface. Sailors noticed patterns they could not explain. Certain routes were faster. Some waters were warmer. Storms followed invisible paths. These observations were recorded in logbooks, passed between generations, and slowly refined. It was not until the 19th century that scientists began to understand the ocean as a connected system. Expeditions lowered thermometers and sampling bottles into the deep. What they discovered challenged assumptions. The deep sea was not static or dead. It was cold, moving, and structured. One of the most important realizations came with the understanding of thermohaline circulation. Driven by differences in temperature and salinity, this global system of currents moves water slowly but relentlessly across the planet. A parcel of water sinking in the North Atlantic may not resurface in the Pacific for 1,000 years. This discovery changed how scientists understood time. Cause and effect were no longer immediate. Actions in one part of the world could echo centuries later in another. Climate, biology, and chemistry were bound together by processes so slow they escaped human intuition. Marine biologists made similar discoveries. Coral reefs, once thought to grow quickly, were revealed to be ancient structures built millimeter by millimeter. Some reefs alive today began forming before human civilization. Their survival depended on stable conditions maintained over centuries, not years. Even the mapping of the seafloor followed this pattern. For a long time, the deep ocean was imagined as flat and featureless. Only with patient sonar surveys did mountain ranges, trenches, and vast plate boundaries emerge. The largest geological features on Earth had been hidden simply because they demanded time to reveal themselves. Each of these discoveries required restraint. Scientists had to accept incomplete data, wait for patterns to emerge, and resist drawing fast conclusions. The ocean did not give up its knowledge easily. It taught humans that understanding comes not from force, but from persistence. Life in the ocean survives under constant pressure. In the deep sea, Organisms live under crushing weight, near freezing temperatures, and complete darkness. There is no room for waste. Every movement costs energy. Every adaptation has been refined by time. Many deep-sea species grow slowly and live long lives. Some fish may take decades to mature. Certain cold-water corals grow less than a millimeter per year, yet live for thousands of years. Their survival strategy is not speed or reproduction in excess. It is stability. The ocean also teaches patience through its chemistry. Carbon dioxide dissolves into seawater and is transported to the deep, where it may remain for centuries. Nutrients sink, circulate, and return to the surface only after long journeys. Productivity depends on delayed returns. Nothing is immediate. Even recovery in the ocean is slow. When ecosystems are damaged, regeneration often takes generations. Kelp forests, deep-sea habitats, and coral systems do not rebound on human timelines. They require conditions to remain stable long enough for life to re-establish itself. This slowness is not weakness. It is resilience. Systems that move slowly are less reactive, less fragile. They absorb disturbance rather than amplifying it. The ocean does not resist change through force. It adjusts through time. From a scientific perspective, this challenges how humans measure success. Short-term gains often ignore long-term costs. In contrast, ocean systems prioritize balance over output. Survival comes from staying within limits, not exceeding them. The ocean reminds us that pressure does not require panic. At depth, pressure is constant. Life adapts by becoming more efficient, not more aggressive. Over millions of years, survival favored those who conserved energy, responded gradually, and remained flexible. This is not a metaphor imposed by humans. It is a measurable outcome of evolution and physics. The ocean does not rush because it cannot. Its processes are bound to planetary scale and deep time. And within those constraints, life persists. Human life increasingly feels compressed. Decisions are made quickly. Expectations are immediate. Progress is measured by visible acceleration. But the ocean offers a different reference point. It shows that endurance often matters more than momentum. That systems built for longevity look unremarkable in the short term. That stability is an achievement, even when it goes unnoticed. The lesson is not to withdraw or slow down artificially. It is to understand which things cannot be rushed. Learning, recovery, trust, and meaningful change follow longer arcs. They require conditions to remain supportive over time. The ocean also teaches humility. No individual wave controls the sea. No single event defines its direction. Change emerges from accumulation, from countless small forces aligned over time. For people, this perspective can be grounding. It allows room for patience without passivity, for effort without immediate reward, for living in a way that respects limits rather than constantly testing them. The ocean does not promise comfort. It offers something quieter, a sense that survival is possible without urgency. That adaptation is more powerful than reaction. That time itself can be an ally when we stop fighting it. When we understand the ocean, we are reminded that we are part of a much larger system, one that values persistence over intensity, one that measures success not by speed, but by continuity. And perhaps the most enduring lesson is this: the ocean does not rush, yet it shapes continents. It does not demand attention, yet it sustains life. It teaches us that patience is not waiting. It is moving at the pace that allows survival. Understanding this does not change the world overnight, but it changes how we stand with